called linear because they are lines, right?
No.
So linear, the word line is in it. So all of the equations that we're going to be dealing with will give us a graph of a line. There's really three methods, and methods has an H in it.
Methods.
I'll make sure I have that not on YouTube. All right. There's three methods that we can use. One, we can use a t-table, basically where we pick our points, what we want to use. Two, we can find the intercepts, and those are two specific points that we have to find. Or we could use the slope-intercept equation, y equals x plus b. You may not have seen all of these yet, but we'll get to them. So we're going to cover all three and show you that you can use any one of those methods and get the graph of the line. So the first thing we're going to talk about is using a t-table. So on the first back of the cover page, it'll say use a t-table. And a t-table is called a t-table because it makes a t-shape. That's what we're calling it, a t-table. And we'll have x on one side, y on the other. X comes first. And we're going to plug in three random numbers for x or y. I like plugging them in for x and figuring out y. That's usually the best scenario. And for the first problem, where it says we're going to graph x minus 2y equals 6. So we can plug in any three numbers that we want. So let's say we wanted to plug in three values. Would it make sense to plug in like negative 100 or anything like that?
No.
Keep the numbers small, keep the numbers simple. Okay. So what are some three small values that we could plug in for x to get y?
0.
0? 0 is always a fun one to plug in. You can plug in 2
And 1.
and 1. Okay, so let's try those. Let's see what we end up with. So if x is equal to 0, let's go to our equation, x minus 2y equals 6. And we're going to plug 0 in for x, right? Well, that 0 is basically just going to go away and leave us with negative 2y equals to 6. And my last step there would be to divide by negative 2. So what do I get for a y value there?
Negative 3.
Negative 3. So we're going to put that negative 3 up here, right next to 0. Okay, so let's try to get another form. So someone called out 2. So let's plug in, we're going back to our original equation, x minus 2y equals 6. We plug in 2 for x. I would subtract this 2 from both sides, correct?
Yeah.
So I have negative 4y equals 4. And if I divide both sides by negative 4, what do I get for y? 1 or negative 1?
Negative.
A negative 1. All right, I agree with the negative 1. And we came up with another value, x equal to 1. So let's plug that in.
For a while.
Oh my goodness, I so messed that up.
I'm like, how did you get 4?
I was
If
trying
I
to hear
moved-
this for thank you for catching that. I appreciate that. Yeah.
It would be 2, right?
Yeah, it's negative 2. Another mistake for YouTube. All right, so our value for y there is going to be 4 divided by negative 2, which is negative 2. All right. So let's change that. Negative 2.
Why is it 2 negatives? Don't that equal positive?
But it wasn't a negative.
Oh, you crossed it out, so you brought it up.
6 minus 2 is the 4 there. So here, if I plug in 1 for x, subtract 1, negative 2y, and 6 minus 1 is 5. Looks like I'm going to end up with a fraction, right? Yes. And that is okay. Fractions are okay. Not the ideal thing to graph, but we can graph it. let's think about this. What is negative 5 halves as a mixed number?
Negative.
Negative 2.5. That makes a little bit more sense from a graphing standpoint. Okay? But as points, you have 0, negative 3, 2, negative 2, and 1 and negative 5 halves.
So that would be 2.5, right?
2.5, negative 2.5, yeah. All right, so we'll go over to the graph, which is strategically located in the farthest corner of the room. All right, so 0, negative 3 would be 0 and then down 3, correct?
Yeah.
2, negative 2, so we've got the 2, down 2. And then we have 1 and negative 5 halves. And if we thought about that as negative 2.5, we go out to 1, down 2.5. So down 2 and then halfway between 2 and 3. Do those points line up?
Yeah.
Yeah.
That's a pretty good indication that you've done the work correctly. If you have a point that's kind of askew somewhere off, go back and check your work. These match up.
And then write your equation.
Draw a line through it. Some instructors want you to write the equation of the line. You don't have to.
Oh.
But if you wanted to, you could put the equation of the line there.
Oh.
To label it. Okay, and there's the graph. So, let's try another one. Any questions on that?
If we would have picked other numbers, would that work too?
If we would have picked other numbers, we would have got the different points, but it still would have ended up on that line. Okay, all right, and we'll see
That
that.
third pointer, that's the 1 and 5.5?
Yeah, 1 and negative 5 halves. Right, which is negative 2.5. So I went down 2 and then halfway between 2 and 3. Okay. So we're still using the t-table. The equation looks still linear, but it looks a little bit different because we have one of the letters by itself on the same side. But we can still use the same process here. We can still plug in whatever we want in for one of the letters and get the other one. Here, it really makes a big difference what letter you pick because it's really solved for one. So you really do want to plug in X values here. You don't want to plug in Y values. Okay. So, what are some values we can use? You can pick anything.
You said that you want to use X.
Always 0.
Negative.
All right, somebody said 0, somebody said negative 2,
And 2.
and 2. All right, so let's try those. So if X equals 0, we plug 0 in for X. Well, that part's just going to go away, right?
Right.
Negative 2 times 0 is 0.
Plus 4.
So we're just left with 4. 0 is always easy to plug in. So if X is negative 2, we'll plug in negative 2. Y equals negative 2 times negative 2 plus 4. What's negative 2 times negative 2?
Negative 4. No, positive 4.
Yeah.
Positive 4. And 4 plus 4?
8.
8. So negative 2 and 8. We got one more value here, X equal to 2. Negative 2 times 2. So negative 2 times 2 this time is?
Negative 4.
Negative 4, all right. And then negative 4 plus 4 is 0. Gives us 0. Yeah, they cancel each other out, this is 0. Just make sure. All right, so we have 3 points again. And no fractions. Even better, right? All right, so let's transfer these points over to the graph. Once again, it's long.
You said long left.
Over here. All right, so how would I plot that first point, 0, 4? Where would that be?
Right 4.
Right
No.
0.
Yeah,
Up
that's
4.
4.
Up 4.
Oh, my bad.
It's a Y value.
That's right.
Yeah, be careful
That's
here.
what I was screwing me up.
0, 4, 0 in the X direction, and then up 4. And the
I'll
Y.
do
That's
it.
the Y direction.
Negative 2, 8.
Two to the left.
Left 2, and then
Up
up 8. Okay. And then I have 2, 0. So where would this one be?
To the right,
Two to the right, up, not at all.
Right, so we'll just draw a point right there on the X-axis.
Yep.
Those do line up. Like I said, if you have one point that's kind of off, make sure you check it. And some instructors like the line label, so we'll do that. Y equals negative 2x plus 4.
I always gotta remember that. I did that all morning.
so the point of this is to get the line straight.
Yeah, every line's going to be straight. Right, so if you have a point that's off, you want to make sure, go back and check your work, make sure you didn't mess up on a sign somewhere or something like that. All right, so to sum up a T-table, you can plug anything you want in, right? But make it easy. Make small numbers. What are the drawbacks? You may end up with fractions, right? Because sometimes you don't know how it's going to work out if you're picking random numbers. So you may get a fraction, but like we saw, sometimes it's not too bad. And 2.5 was an easy fraction to graph. Okay, so that's using a T-table. So we're good here. Ready to move on to X and Y intercepts? Okay. Left the eraser again. So, what's in there? So if you turn the page, we're going to find the X-intercept, the Y-intercept, and a checkpoint. Why the third point? You really want to make sure your graph lines up. So the X-intercept is one point, the Y-intercept is another point, and you have that third point kind of as a check to make sure everything's lining up the way it needs to. Okay. So it says graph
X minus 2Y equals 6.
Well, that equation looks familiar, doesn't it? That was the first one you did with the T-table. Even though we're using a different method, should we end up with the same line?
Yes.
Yes. Different points probably, but we're going to end up with the same line. We'll check it after we graph it if it looks exactly the same. So for an X-intercept, that's a specific point. An X-intercept means that Y has to be equal to 0. Right, that means that's a point on the x-axis, right? And every y value on the x-axis is 0. So if an x-intercept has a y value of 0,
Then X.
a y-intercept will have an x value equal to 0. So let's plug those values in. So x minus 2y, if I plug 0 in for y,
So how do you know which one you? Oh,
It
you
says to
mean,
find the X, so that's why you put it in.
right?
X equals 0, Y equals 0 for the moment. But
Yeah, for the x-intercept, we're plugging y equals 0 in.
Okay.
For the y-intercept, when we get there, we'll plug 0 in for x.
so graph X, so would you put the Y right here too?
No, your wire's gone, because you plugged in the 0 for
Okay, that's a 6 at the end, sorry about that. All right, so if I plug 0 in for y, what's going to happen to it?
You can't, it would be
It's
0.
going to be 0, so it's going to go away. Right, so I'm just left with x equal to 6, correct?
Uh-huh.
Okay. So as an ordered pair, as a point, what is that?
That's
Six
6 and
and
0.
0.
Correct.
Okay.
All right, so that's the x-intercept. So let's go to the y-intercept. So I'm going to use the same equation, but I'm going to plug in 0 for x. I have negative 2y equal to 6. So y equals negative 3, correct? So as an ordered pair, what would that point be?
0 and 3, negative.
0, negative 3, right? I put 0 in for x, got negative 3 for y.
How do you do the, what do, I'm sorry, y'all. On the second one, I don't get that.
Okay, I plug 0 in for x,
Oh, you put 0, oh, I got what you say there, okay, never mind.
and I want a third point, so I need to find a checkpoint. The checkpoint can be anything other than either of these points. So you don't want to plug 0 in. You don't want to plug zeros in for x or y, and you don't want to plug 6 in for x, and you don't want to plug negative 3 in for y, but anything else will work.
2 and negative
Well, you want to plug in 1.
2. Okay, 1.
You want to plug in 1 for one variable, you want to plug in for both of them.
Oh, okay, 2.
Okay, for what?
X.
Okay, so we'll say x is equal to 2.
Do you have to always do checkpoint, or is that checking it?
Some instructors want you to have 3 points. Actually, most of them do.
Did we do checkpoint?
Yeah, she wants 3 points.
I know, but did we do checkpoint?
She didn't show us how to do that, but she wants.
Well, if you have an x and a y-intercept, that's only 2 points. You're going to have a third point
So
somehow.
how do you do, so I don't remember how we did that.
Well, this is basically, I'm just picking a random value.
Oh, random one. Oh.
Whatever you want.
Oh,
You
As
guys
long as
do-
it's not one of the
When you're
these
using
values.
exactly the same formula that you used when you were using 0.
Yep.
So we
So-
put it in this X?
Yeah, I'm just plugging into the same line that we were given. So somebody said 2, so we plugged in 2 for x. 2 minus 2y equals 6. Subtract the 2. 6 minus 2 is 4.
This may be a really bad retarded question, but could we, so yeah, you know how we did y at 1 and then x is 1? We did checkpoint as x, could you checkpoint as y?
You could have checkpoint 1.
That's what I'm asking, you can do that,
Yeah,
either one?
basically this
Okay.
is basically the same thing with the t-table.
Okay,
Plug in anything you want,
okay, so wherever.
as long as it's not those 2 guys.
So what's the point?
So what is this point?
2 and negative 2.
Right. We plugged in 2 for x, and we got negative 2 for y.
Okay.
We have 3 points, so let's move over to the graph. Remembering to bring the eraser. So let's plot our x-intercept, 6, 0. Go out to 6 on the x-axis, plot your point. Your y-intercept, 0, negative 3. Run into negative 3 on the y-axis. And our checkpoint was 2, negative 2. 2, down 2. Those points line up. We're good to go. And that was x minus 2y equals 6. All right, so let's look at the graph we did for the first one using the t-table. Do the graphs look the same?
In essence, yes.
Yes, they're exactly the same. We came up with different points, but the
yeah.
lines are exactly the same. All right? Some of the points actually were the same.
Here.
We have the same line. So we used 2 different methods to graph the same line, and we got the same line.
Which ones were those on the graph? Which one you start off with? 6
The
and
very
0?
first one.
6, 0?
Wouldn't it be, I thought it would go up first, huh?
But that's the next intercept, right? So it needs to cross the x-axis. It needs to be 6 on the x-axis. So we good on that
And then
one?
the y axis would be negative 3.
Right.
I always think so simple until I sit down for homework. What are you?
2, negative 2.
What helped me on that is whenever I have a graph, I write the
X and the Y, yeah.
All right, can I erase this information? We'll move on to the second one. Do the same steps.
Hmm? You just want to see my answers?
On Tuesday.
Sure.
Is that okay? It's okay. Thank
All right, the second equation is just like the second equation was for the t-table, minus 2x plus 4.
So, question, real quick, with the checkpoint, you always use the t-table, right? It's the same thing as the t-table.
Yeah. All right, so let's find the x-intercept. And that means y is equal to what?
0.
And we have the y-intercept, that means x is equal to
0.
0 on a checkpoint. We'll figure that out after we figure the x and the y-intercept out. So So if I'm finding the x-intercept, I need to plug 0 in for y. So I have 0 equals negative 2x plus 4. What can I do here?
Subtract
You
4.
gotta move the 4 over to the,
Right, you can move the 4, you can move the 2x.
Oh, either one.
Either one.
2x is probably easier, huh?
Yeah, I'm gonna move the 2x over. But you could move the 4 over, or you're still gonna end up with the same answer. I just like my variable a little less.
Yeah, that's why I said it was probably easier.
So 2x equals 4, and
And
then
then
if I divide
divide.
both sides by 2,
So x equals 2.
x equals 2. So as an ordered pair, my x-intercept is
0,
0.
0, 2. No, x2.
No,
X,
2,
I mean 2,
0.
0. The x first.
So remember that the y value has to be 0 for the x-intercept. So,
But doesn't x always go first, right?
right,
In the when you write it together.
right, alphabetical order, x before y. So x equals 0 for our y-intercept. Y equals negative 2 times 0 plus 4. Well, what happens to the x part here? It's a 0, so we're just left with 4. So what's my y-intercept going to be?
4.
0.
Oh, 0, 4.
Right, 0
That's
for
right,
x,
I'm sorry.
4 for y. Now, as a checkpoint, you can plug in anything you want as long as it's not something you already have on the table here. So you can't plug in zeros if you can't plug in 2 or 4.
1.
One?
Somebody said 1, somebody said 3. Doesn't
1.
doesn't matter though, right? Whatever you want.
Good one, B. Let's go with 2.
It doesn't matter. Yeah. You can plug in either one, it's going to come out to be a whole number.
Oh,
Now the checkpoints are gonna be on the X all the time? Checkpoint gonna be on the X all the time?
You could have picked y, but x is really easier to plug in here. Because if I plug in a number for y, I'm going to have to move a whole bunch of stuff over. So,
it'll be 6, right?
negative 2 plus 4.
Oh, negative 2, so it'll be it'll be 2. That's a negative 2, my bad.
So my checkpoint will be,
0, 2.
I agree with the 2,
1.
1. We plug in the 1.
I'm sorry.
Yeah, we picked,
Lord
we picked
forgive me,
1.
y'all. I'm having a rough day, a rough week.
Yeah, we have 3 points, so we can move over here. So where's my x-intercept at?
2.
2, 0, so we got the 2 on the x-axis. Y-intercept? 0, 4.
Down, up 4.
0, 4. And my checkpoint was at 1, 2. So over right 1, up 2. Those points line up.
Yes, sir.
Does it look exactly like the second equation we did with the t-table? Yep. Yep. Same line. Different process, same result.
Wow.
Label the line. Like I said, some instructors like that and some don't. It's up to your instructor if you have to do that or not. All right, so 2 methods down. T-table, using the x and y intercepts, and a checkpoint. So we have 1 method left, and if you're in 310, I don't know if you've gotten to the
We did that
slope
Yeah,
and
we
y
did
intercept.
today.
Computer
Okay.
science news today.
So we're going to cover that. And I'll show you eventually why the third one is always the best one to use if you're given a choice. All right, so let's move over to the next page, which is using the slope intercept form. Y equals mx plus b.
I like that actually.
Yes, it's the easiest of the 3.
You just have to memorize that formula.
So let's talk about this equation for a couple seconds. You only really need 2 pieces of information from a linear equation to graph it. One is the slope, and that's going to be represented by the letter m. Why the letter m? Learning the French. The French came up with the
You know what you said?
that the letters m and b were used by the French for this type of equation, and it stuck around. So that's why the slope is called m.
From a mountain.
And the y-intercept is going to be b. But it has to be in this form in order to get that information. Y has to be by itself. So, our first equation, really familiar with this one now. X minus
2y.
2y equals 6. Is it in this form?
No.
No. So we have to rearrange it a little bit. Always move the x piece first. So if I move the x over to the right, what do I have to do?
Plus,
Make it a negative.
no, negative,
First,
negative.
make it a negative x.
Alright, I subtract x. So that's going to leave me with just negative 2y on this side. And I have 6 minus x on the right. Notice that my x part comes first, so I'm going to write that part first. Negative x, and that's still a positive 6. Okay. So I still need to get y by itself. So what do I need to do now?
Divide.
By
Two, negative 2.
negative 2, right? We're going to get rid of the whole thing. So we're going to divide everything, every single piece, by negative 2. So we've got y, that's good, that's our goal. Now we have this negative x over negative 2. What does that mean?
1/2.
1/2, right? Because technically that's a negative 1 right there. And a negative divided by a negative is positive, so that's a positive 1/2 x. And then 6 divided by negative 2, negative 3. Once it's in this form, we can get our slope and our y-intercept. So what is our slope? 1/2. It's the number in front of x. What's our y-intercept?
Negative 3.
Negative 3. This is all the information you need to graph the line, but what does it mean? Okay. Well, a y-intercept, that means x has to be equal to 0. So as an ordered pair, what is that y-intercept of negative 3?
0, negative 3. 0, negative 3.
Oh, because
Correct.
the b is the negative y, right?
Right.
I mean, b is the y, not negative.
This is your starting point. This is what you graph.
X would be the end.
This is what you, no, m is your slope. It won't have anything to do with x at all. This is your starting point. This is what you have to graph first. The slope means nothing without a starting point. So that's what the y-intercept is. The slope can be thought of as rise over run. So rise meaning up or down, run meaning left or right. So if I have a slope of 1/2, that means I'm going up 1
Over 2.
and over 2. Right? I'm rising a positive 1, running a positive 2. Okay? If they're negative, they're going to be going in opposite directions. But in this case, they're both positive. Positive means up and to the right. So let's transfer that information over to the graph. What is our starting point? What's our y-intercept?
0,
Zero.
down 3.
Down 3. From our y-intercept, we're going to use our slope to find more points. So from my y-intercept, what is my slope? What am I doing? Up 1 over 2. If I wanted to get another point,
Up 1 over 2.
up 1 over 2. No work, right? No other points. Just work with the graph and the information that you're given.
And up 1 over 2 as many times as you need.
Yep, but those are 3
We only
points,
need
right?
3, so
Line up perfectly. And that's x equals 2y equal to 6. Does that line look like the first one we've done on the t-table and the first one we did with the intercept?
Yes.
Different method, but it's the same equation, it's the same
I
line.
thought that side of here was all negative. That was positive,
Positive.
yeah.
Okay.
So really what the equation is saying is that the x-intercept equals your starting point plus your slope. That's what the equation is actually telling us.
Yeah, basically what the equation is telling you is I have a y-intercept of negative 3.
Okay.
And then I'm going up 1 and over
And
2.
then I have a slope, a change in,
Which will give me my next y-intercept.
your next,
Et cetera,
your
et
next
cetera,
order
et
pair.
cetera. Or down, down, down.
Exactly.
Okay.
So are we good on this one? We got another one.
So let's do another.
All right, well, that'll be the second. All right, so are we good? Can I erase this information? Well, the next one's nice. It's already done for us. It's already in the form we needed. Y equals negative 2x plus 4. We don't have to rearrange anything. We can go straight to the information that we need, which is the slope and the y-intercept. So what's our slope?
It's 0.
Yeah, it's just a number in front of x. Just negative 2. What's our y-intercept? 4. Okay, so well, let's clarify what this information means. A y-intercept of 4 means it's the ordered pair, what?
0 and 4.
0, 4. Remember, a y-intercept always has an x value of 0. Remember that the slope means rise over run. And we have a negative 2. Remember, as a whole number, you can put it over 1. It means the same thing, right? That can represent your rise over your run. So if I have negative 2 on the rise, does that mean I'm going up 2 or down 2?
Down.
Up. Oh, on the rise.
Right. Negative 2, right? Because the last one was positive 1 and we went up 1. So we're going to be going down 2, and then I'm over 1, that's a positive 1. So that means I'm going to the right 1. So what do I have to graph
The code
first?
is done for you.
The
Exactly.
Y, the 0, 4.
Okay. So 0, 4 is my y-intercept. Remember, I have to graph that first. And then I need to go from there, what?
Down 2.
Down 2 over 1.
Down 2 over 1. If I wanted a third point,
Down 2 over 1.
down 2 over 1 again. 3 points.
Let's see.
Huh.
That one's pretty easy, right? It was already given to us. So we don't have to do anything on that one. Alright, so there you go. There's your line. Does it look like the second equation on the t-table and the intercepts?
Yes.
Yeah, same line. So those are the 3 methods. On the next page, we have 2 things to graph. Doesn't say what method you have to use, but I'm going to show you why the third method is the best. Can I erase this info? So let's graph 4x minus 5y equals 0. All right, and let's say I got these 3 methods here. I've got a t-table, I've got intercepts,
And slope.
and I've got y equals mx plus b. All right, on a t-table, I can plug whatever I want in, right? Okay, so let's try something. Try anything you want.
0.
Okay, let's plug in 0 for x. If I plug in 0 for x, what am I going to get for y? Okay. So let's try another. Remember, we need 3 points.
Negative 4.
So negative 4. So 4x or y?
4x.
Okay. Well, it's not that it doesn't work, we just get a nasty number. That's the thing with the t-table. You never know what you're gonna get when you start plugging random numbers in. Yeah, you're gonna get points, but you may get points like -4 and -16 fifths, which I really don't want to grab. Right? So, let's stay away from the t-table. Well, let's try the intercepts.
My favorite one.
I'm just trying to prove a point here, to see what is going to be the best. All right, so intercepts. If I have x-intercept, that means y is equal to 0, correct? And for y-intercept, that means x is equal to 0. So let's plug in 0 for the x-intercept. Yeah, we're running into the same thing we did here. We're going to get y equal to 0, right? So if I plug x equal to 0, so I switched those up, didn't I? Yes, I did. I did the y-intercept first. Strike 3 for you two today.
It's because you know you're on time.
Yep. That's exactly what I did. All right, so I found the y-intercept. I plugged the x equals 0 in for x, and that gave me a y value of 0. So now I'm going to find the x-intercept. I'm going to plug 0 in for y. So I get 4x equal to 0. I get 0 again, right? Well, that's the same point. So I'm going to have to go back to the t-table to find more points anyway. Well, we saw that kind of sucked. So we'll go with that. So I'm hoping y equals mx plus b will be a little bit better choice here. So we've got 4x minus 5y equal to 0. Is it in slope-intercept form?
No.
No, but we can take care of that. We can subtract 4x from both sides. Negative 5y equals negative 4x.
Plus the,
Divide by negative 5, right? We got to get rid of that negative 5. So y equals, I have a negative divided by a negative. Right. Okay, so I know there's nothing back here, but all that means is that my y-intercept is 0. What's my slope? 4/5. So y-intercept of 0 is 0, 0. That's that point. That's the origin. And a slope of 4/5, that means I'm rising 4 and running 5. So I'll go here. Where's my y-intercept at? 4. 4. And the y-intercept is at 0, 0. That's our starting point. Slope, 4/5, up 4 over 5. So up 4 over 5. Down to the third point, up 4 over 5. Labeling my line, 4x minus 5y equal to 0. So out of all three, the slope-intercept was the only one that worked. That's going to be the thing. Sometimes one method will work for better than the other, but this one, if you're given a choice, this will work for every single linear equation. So if you're given a choice, always go with this one, because you know you're going to get the answer out of it. The other ways, sometimes trouble occurs, and we don't like trouble. We want clean and neat, and it works.
So for the y equals mxb formula, the x and the y-intercept will still be 0?
Well, in this case, we got a y-intercept of 0, right? Because there wasn't anything added back here. So that means our y-intercept is 0, and for a y-intercept, x is always 0.
And
so it's
the
all-
m is which creates the points.
It'll always be 0, comma something. It's always going to be 0, comma whatever this number is back here. Okay. So good on that one? Yes, correct.
What section is that, Kurt? 7.3 or 7.4?
Oh.
I think that's seven, too.
It's
I think it's 3.
I think it's
probably 7.3, if I remember correctly. Since I switched the book over, I'm still trying to remember what the sections are.
It's okay.
Yeah, but. Actually, fractions help with slope. Your rise and run
It's
are
already
given.
kind of there for
Yep. It's already in slope intercept one. So let's use the slope and the y-intercept. What's the y-intercept here?
0, 0.
0. And that's the point 0, 0. There's nothing added or subtracted back here. What's my slope?
negative 4 down and 3 left.
Right.
Ours is both negative because it's in.
They can't both be negative. That's what I was just going to ask.
Ah!
Right? Because this means something different. Right? Because a negative divided by negative is really a positive. My suggestion, if your fraction's negative, move the negative up to the top. Because that's going to tell you I'm going to be moving down 4. That 3 on the bottom is positive. I'm going to move right 3. Okay. So that's something, means something different if you apply the negative to both of them.
If it's negative, you just basically, they're both negative, it's basically just a positive.
Yes, exactly. Because a fraction represents division.
Right.
So negative divided by negative will always be positive.
Positive.
Exactly.
So, if the bottom number was 3, you will rise 4, but when you went to, you will run to the left, to the negative side, right?
If it was positive,
If the 3 was negative.
If the 3 is negative. But my suggestion is don't even worry about that. Always move the negative to the top.
Okay.
I mean, just as a
Because
general rule, you never have a negative number at the bottom of a fraction.
I've been doing it for a long time, and I never run to the left. I always run
You
down
can,
to the
but
left.
eh,
Yeah. Okay.
I would stay away from that. All right, so let's graph it. What's my y-intercept?
0.
0, 0.
And my slope is a negative 4/3.
So down 4.
So I'm going to go down 4.
And over to the right 3. You want 3 points, you'll do it one more time.
Right, and you're going to go down 4, and over 3 again. Now granted, you can do the opposite. Right, down 4 over 3, that gave us our 3 points. But sometimes you may run out of room, or your graph's not big enough. You could go to the exact opposite. So you can run to the left, but there was no need to here, because we had enough room. There's your line. Y equals negative 4/3. Now, there's a couple things in the last page. All the lines we did dealing with have slants to them because they have some kind of slope involved. But there are vertical and horizontal lines. You need to know how to recognize those as well. Those are the ones that are a little bit different than the rest. So let's say I have, it says graph, x equal to -5. Well, how is this one different from the rest of the equations we've been dealing with?
I'm trying to get it into you.
There's no y, right? So it has to be different.
you know, they're given.
Yeah, it's x equal to -5, but it's a linear equation, so we have to come to the line. So what I'm going to say is this is going to be a vertical line. Right? And why would it be vertical?
Because the y is undefined.
So where is x equal to -5 on my graph?
5 to the left.
To the left.
5 to the left. What's the x value at this point?
-5.
What's the x value at this point?
-5.
What's the x value at this point?
-5.
Notice that these points all line up on a vertical line. So what it's saying is no matter what y is, x is equal to -5. right? That's why it ends up being a vertical line. So that's the line x equal to negative 5. An easy way to think about it is go out to negative 5, and whatever hash mark is going through that line, that's the kind of line it is. Okay, so notice the hash mark going through it is vertical, so we're going to make it vertical. Well, if x equal to a number is vertical, what do you think y equal to a number is? Maybe horizontal.
The opposite.
Yeah.
It does look like that. So where's negative 5 on the y-axis?
Down.
Down 5.
Down 5. So what's the y value of this point?
Down 5. Negative 5.
What's the y value of this point?
Negative 5.
What's the y value of this point?
Negative 5.
Y equals negative 5 on this line all the way across, and that's a horizontal line. Once again, an easy way to remember it. Look at the hash mark that's crossing the y-axis there. It's horizontal. Right, the hash mark is crossing horizontally. That's another way to remember it. Also, there's something special about their slopes. A vertical line has an undefined slope. Another way, some instructors will say it has no slope. It doesn't exist. A horizontal line, its slope will always be 0. It's flat. Right? There's no rise there. So it's always equal to 0. So that is your two special cases. So basically, summation, if you're given a linear equation and it says to graph it, if you're given a choice, go with slope intercept 1. You do have to sometimes use these, especially if the directions say you have to find the intercepts or use a t-table. You know, your instructor will have that on their test where they want you to do it in some specific manner. But if you're given a choice, you can always go to this one. It'll always work. These are your two special cases. If you have x equal to a number, it's going to be a vertical line. And y equal to a number, it's going to be a horizontal line. And that's basically all you need to know about graphing lines. Anything else I can answer? Kind of close.
Well, you said when graphing linear equations, how do you determine if the equation is linear?
If the power on x and y are both 1. You can't be anything higher than power of 1.
So think about 2x.
It can't be x squared.
Oh,
Or x to the third, square root of x, something like that.
okay.
And the power will always be 1 on both of them. Okay. Anything else I can answer? All right, we're great.